So let's get going. So thanks for the opportunity to come and chat today. I thought I'd spend a little bit of time today talking about GitHub as a team sport, what it means to be a good teammate, and some things that you can do to make it easier to work together. And we're going to talk about some GitHub features, but also some best practices that you can follow to help make collaboration easier across teams. Before I get going, just a little bit about me. So I work in product at GitHub. I live in Edinburgh. I've been here about 2.5 years. I've been at GitHub for about 6 years, but I've used it since about 2008. And I've done lots of work in and around open source projects. And so a lot of what I'm going to talk about today is really things that open source projects do well and sort of patterns that we can copy and use elsewhere. They are not actually unique to open source. So this is my current avatar, and that is my beautiful daughter standing behind me pulling I don't know, not sure what's going on, but anyway. Yes, so some working assumptions that I am making while giving this presentation, and let's test those if these aren't quite right, but based on my conversations with Joanna and others, the STA is, a project with, or collaboration with lots of projects, lots of things that you're working on, many volunteers working on those projects. The projects are sort of, oh, look at that typo, projects built by many teams. Projects move between teams. So, there's sort of some handoff. It's not like you'll be on a project the whole time. So maybe adopting standard conventions for how you set up your projects will help you be more productive when moving between. And we're all volunteering. So time is limited. And so really we should be focused on our time when we're volunteering on maximizing the value, writing net new code, fixing bugs, rather than, for example, installing software, trying to get your dev environment set up, that kind of thing. So these are my base assumptions based on my conversations with you all. And so let's talk about what we're going to go through today. So first things first, feel free to interrupt me. I don't mind being interrupted. It's fine. I'll probably recover gracefully, I hope. Feel free to ask questions in in Zoom chat. Happy to respond there as we go, and I'll try and just answer it as I speak. But if you see something where you're like, hang on, what are you talking about right now? This seems wrong, or I'm confused, just say, and we can dig into that. We've got a small enough group that I think we can probably just answer stuff. So rough plan, three sort of distinct parts of this talk. One is work like an open source project. What do open source projects do well? What are some conventions they follow that I think every group, every collaboration can adopt? Then we're going to spend a little bit of time talking about automating work and letting robots do heavy lifting. And I'm going to end talking very briefly about code spaces and how those are sort of, in many ways, a sort of culmination of certainly the automation part, and can be a real productivity boost to teams. So what do I mean by work like an open source project? Well, I mean, one of the things that I like, one of the phrases I like about open source is that they have to sort of adopt reproducible work patterns out of necessity. One of the challenges with open source is you're not all in the same room. You don't necessarily even be on the same time zone. You might not know the people you're working with. So adopting some patterns, conventions, documentation standards, that kind of thing, can really help people know where to go and find their way around a project, and make a reasonable headway without having like a Zoom chat or an in-person chat. But as I said before, none of this is unique to open source. These are actually patterns and conventions born of open source communities, but ones that can be used elsewhere. And so today I thought to illustrate some of these, to walk you through the Linguist project, which is actually one of GitHub's more popular open source projects, and one that I was a contributor and maintainer of for quite a while, not anymore. Just very briefly, what does Linguist do? Basically the thing that decides what programming language GitHub thinks your code base is written in. And so this breakdown is derived by linguist, and also the color of the bar is determined by linguist too. So if you really dislike the light blue of TypeScript or whatever color it is on GitHub, then you can make a pull request to this library and ask to change it, and see how you get on. People like to fight about color schemes. Anyway, so first things first. This is especially important to open source, but it is actually important in many projects, regardless. Like licenses are important. If you don't use a license, it's not clear how people can reuse your code. Don't write your own. There are plenty of very good licenses that have been written by lawyers and communities over years. The formatting of choosealicense.com is a really good website for just talking you through, like, what are you trying to achieve with a license. But if you use a license that's a standard one from choosealicense.com, GitHub will pretty reliably detect it. So in this case, for linguist, to MIT open source, as called permissive open source license. Kind of table stakes, but worth doing. A README, a little bit probably more important than a license for contributors, but licenses, again, are very important to some people, less important to others. But the README is really like your homepage for your project. So, standard guidelines here, say what this software does, how, like, pointers how to install it. What are the most common usage scenarios that this project is designed to address, and also maybe a section on how to contribute. GitHub, you can write READMEs in Markdown, restructured text, plain text. They won't format quite as well. There is actually a pattern that you can adopt here, which I kind of like, which is, you see people do this, they call it README-driven development, which is the idea where you actually write the README before you've written the software. The idea being that the exercise of writing down what you are intending to build and explaining its functionality to people helps you think through what you should build. And so this idea that start with the README, even like, say, if you're building an API, like design the API, say these are the API endpoints, this is the type of response they give. You can actually get a pretty long way in design by thinking through how you'd explain the software to somebody else and the package to somebody else, and then building the software to meet that spec. So this is kind of like the extreme version of READMEs, where you write it before you've written any code, but this is kind of a fun pattern to follow. Arguably essential for public projects, but useful in many. Code of conducts are pretty standard these days. Basically a code of conduct establishes expectations for behavior amongst your project's participants. There are many standard good ones. This is a contributor code of conduct, contributor covenant code of conduct from the GitHub adopts on most of its projects. But you'll see some communities will have their own extensions to these. So one community I'm involved in has this kind of rule about no tool shaming. So people might have moved from like a legacy code base. Maybe they used to write all their stuff in Fortran and now they're writing it in Python. You're not allowed to, badmouth Fortran. That's like a rule of their community, and that's okay. That's they don't think that's helpful. So you can have your own rules. Again, there are lots of good codes of conduct that you can adopt. I forget who it was that was saying that they fell asleep reading security policies earlier, but actually saying, especially for something that's publicly facing, being clear how you can report a vulnerability is actually pretty important. This can be really important for public code bases as well, where you might not want somebody to disclose the vulnerability in public, because that might be by itself a security risk. So how and where to disclose security issues, again, it's just a good pattern to adopt. GitHub has, I don't know if you can see here, but for lots of these things, if you have a security.md, which is what this file is called, it comes up under the security tab and it shows up as a specially detected file. So lots of these things get special treatment if you follow these conventions. And then just one more, again, contributing.markdown. This is linked to from the README on Linguist, but this is more detailed information for somebody who might actually contribute code to the project. So, this is, for example, these will vary substantially by project, but this might be, saying this is what we expect you to, how we expect contributions to come in. This is how you can debug the code base, how you can run it in like test mode, whatever it is that you think a would-be contributor needs to make a successful contribution, often will go in the contributing file. Also, in this case, the current maintainers listed here are listed as well. So a couple of extra things that might be helpful, and this is sort of useful for projects where you get a lot of feedback, or maybe you've got a team that you're working with and you've asked them to open issues to ask for feedback or give you bug reports, that kind of thing. There's this thing called issue templates on GitHub where you can effectively just it's actually in a special folder called .github issue template, and then just a collection of markdown files at that path. And what that changes in the UI is when somebody goes to open an issue, they get prompted to pick from one of the options. And so what that means is when you go to open an issue, you effectively have kind of placeholder information that you want to capture. So if you have a particularly successful project where you get lots of feedback, one of the challenges with triaging that feedback can be that people won't necessarily include all the information that you need to make a good decision and triage that request. So issue templates are a good thing for that. You can also use pull request templates. So it's exactly the same idea. What happens when a pull request opens? And so this is the one again from Linguist. And so let's actually look at a pull request here. So this is somebody adding a pull request. They're proposing a change to Linguist here. And you can see that pull request, they've got a checklist to work through, and they're filling in all the information that the maintainers want of this library, of this project, to use to take action. So this checklist. In fact, I recognize some of these items. This is a checklist born out of experience of these maintainers, where they're like, well, every single person who opens a pull request, we know we always want this information from them. So put it in the pull request template. So those are some basic conventions around sort of setting up different files, configuring issues and pull requests. Let's talk a little bit about what happens when a pull request is opened, when somebody makes a change. One thing that can be really helpful when a pull request is opened is who gets notified to make a review, to come in and check the changes. Sorry, this is a little bit small probably on your screen. Hopefully you can see it okay. So this is a special file called a code owners file. And this is again in the .github folder. And this is effectively just a way of saying for what areas of the code base who should be involved in the review. So the line 4 here is a star. So that's like, this is a wildcard match. And it says for any change in the project, ping this team GitHub Linguist reviewers. And this can be an individual, it can be a team. And there's a link here about code owners. This is a really nice way if, for example, you have had different aspects of the code base built by different people and they have different expertise. If you see changes coming in, for example, to the front end, like style sheets, HTML templates, maybe JavaScript, you can say, well, if it's in these code paths, ping this team. Maybe if it's something in the sort of database config or the application layer, you can say, ping this other team. So you can have path-specific rules that when a pull request is opened, it automatically mentions that individual or team. And so this is a really nice feature for making sure that not everybody gets notified for every single pull request that comes in. This brings me to one thing, which is, and I would say this is especially important, I would guess, for the Scottish Tech Army, is I think a really good convention to adopt with projects is to focus on teams rather than individuals. So, teams can be staffed by just one person, or it can have many, and you can rotate membership, but teams are a more durable way of maintaining a project's presence. It allows people to take holidays, leave a project, not always be pinged for every single request. So one convention I strongly encourage projects to adopt is to use team mentions and manage the team rather than have individuals on the hook for things. It's generally a better way to manage a project, kind of ownership and maintenance. Okay, so that's the first thing. That's my first section done. Wanted to just talk about some things that we see open source projects do. Next, I want to talk about automating some of the work around a project. So, one of the ways I think about automation is just identifying the work that's not interesting. It might be hard, but it's not interesting, but it's done by most humans involved with the project. So let's automate things. So let's look at that. Well, let's look at, some examples of things that people have to do basically every time they download the code base and want to get it running or make a change. Well, most people are going to want to install the dependencies. Maybe you need to download some test data to bootstrap the application to make it have something in the app before you can test it that it's working. Maybe you need to install a database tech, MySQL or Postgres or something. All of this is sort of core setup. Then most people are going to want to run the project. They're going to want to run the app. Probably going to want to run it locally to verify the changes that you've made. And then hopefully people are writing tests and fixing tests and not breaking the build. So hopefully you're running tests and then, and then obviously contributing the changes back up. So one approach that I really like is this, and this is actually a pattern that GitHub extracted for itself. So this is, there's a repo called Scripts to Rule Them All, is to have scripts for all of these common tasks. And these are not the same scripts, but you find them in the same place. So the idea is that you have, script bootstrap, setup, update, server, console, test, build. You have all of these scripts, and these accomplish all of these different tasks. The idea is that this is just a convention that you follow. So when you go to a project, you know that in the folder script bootstrap, there is a file that its sole task, that sole script, this is usually a bash script or something, its sole sort of focus is installing or updating dependencies that are required to run the application. That's all it does. Setup maybe does the first initialization of the app. So maybe this is the thing that creates databases, templates out, a development and a test database. You might run setup again if you break your dev environment, for example. Script update is usually what you would run. Maybe you've already got the project on your machine, you've already got a Git clone, you do a pull. Update might be, maybe there's it might run bootstrap again, or it depends on the project, but update is something you would run once you've run git pull. Script server is, as you might expect, run the app, run the code base. So if it's a node project, this would be like npm start. But for anything more substantial, it might be start Redis, start MySQL, start Node. It could be a whole bunch of different things. You might compile CSS first or something if you're using some kind of CSS framework. Script test is pretty much as it sounds, run the test suite. Maybe you've also, and this is kind of a convention we adopt at GitHub, build that script in a way that it will accept a file path argument so that you don't have to run all the tests. Maybe you've just modified one test file, so you run script test and pass a file, and that will just run that test. Actually, I can't run all of the tests for github.com on my laptop. It would take like 3 days or something. So this is especially important for larger projects where you want to test like a single part of the code base. CI build is a little bit more specialist. Run the app might be. Oh, sorry, I've got this wrong. This would be run the CI test, and then console would be run a console session for your application. So if you want to like exercise the domain model, you want to run it locally, but not in server mode. In truth, these are the three that are most important: bootstrapping, server, test. The others are a little bit more specialist. If you only had to adopt three, I would say it's these three. And let's just have a look at one. So this is actually Linguist's Bootstrap. So again, I said you can see here script bootstrap, script CI build. We don't have all of them in this project. There doesn't really make sense to have a script server for Linguist because it's not an app that gets served, it's a library. But what does this bootstrap file do? Let's have a look at it. So again, it's a shell script. Firstly, it checks if there's a brew file, and if it's Mac OS, it says brew bundle. So this is installing. Check if there's any updates from Homebrew, and if so, installing them. This is a Ruby gem, so we have a configuration parameter set here to make sure that the gems are built locally. And then this project makes extensive use of submodules, Git submodules for all the different languages and different syntax highlighting. So initialize and install all of those. And then there's this Linguist specific task, which is to generate a set of sample files. This is a specific thing. But the point is, if you run script bootstrap, it runs all these things and should get you up and running. So yeah, so have a look at the one scripts to rule them all pattern. If you haven't seen this before, it's a great set of conventions for teams to follow. And again, if you pick up a project another team's been working on, you find these files there, then if you can't, first thing to try would be to just run script bootstrap, see if you can get it running. And more often than not, if the team is maintaining those files, then you'll be good to go. Okay, let's spend a little bit of time talking about the sort of execution engine for some of this automation. So maybe some of you have used GitHub Actions already. I thought to spend a few minutes talking about that. So GitHub Actions is effectively a cloud-hosted compute service, which is available for a bunch of different architectures: Linux, Mac, Windows, ARM, and it's free on open source repos, on public repos, actually, I should say. It doesn't even have to have an open source license. Free on public repos. The idea is, one of the most powerful things about GitHub Actions is that they can be triggered based on any event that happens on GitHub. And I'll show you a little bit more what that means in a second. But let's have a look at, again, let's go back to Linguist, look at the GitHub Actions config here. So this is in a folder called Workflows, which is the default place for GitHub Actions to live. And it's a YAML file called ci.yaml. And this workflow is triggered. There's only one workflow here. It's triggered by a push or a pull request to the default branch, which is called master on this project. And so you can see the on statement at the top, line 3 is saying on these events, trigger the workflow. Then there's a concept of jobs and workflows and steps. So you can have effectively a workflow with multiple different steps in it. And this actually does have multiple steps. So this is there's a task, there's a workflow here called Ruby, and then matrix.ruby is a special variable, which is to just say that we're going to go, well, it's picking up the matrix later. We're actually going to test this library because it's a Ruby gem. We're going to test it on Ruby versions as old as 2.6 and as modern as 3.1, which is the latest version of Ruby. And we can see that it's going to run multiple steps. So this is effectively going to eventually run the tests for the project. And it happens again when there's a push to master on the default branch, push to or pull request to the default branch, sorry. So what does that look like when it's actually running? Well, this is a pull request where the actions are running. And we can see here, we can see the build matrix here. We've got the 4 different types of Ruby, and we've actually got different workflows. There's also a Docker file that gets created and tested. And then there's actually because this is a library that tests different programming languages and tries to identify them, there's actually a test called this classifier cross-validation test, which is testing if we're sort of breaking the language detection. So it's sort of a Uber integration test for the library. So this is what it looks like when it's running. But when can it run? And so, this one is happening on pushes and pull requests. But one of the kind of exciting things about actions is effectively any event on GitHub, whether it's somebody commenting on a pull request, whether it's somebody opening an issue, whether it's somebody adding a label, anything you can think about happening on GitHub, there are events that are triggered, and you can have a actions workflow that listens for those events and then is triggered when the rules are matched. So that means you can automate all sorts of things with actions. It's not just for running tests. It's not just for pull requests. It's for all aspects of workflows. And so people build these really powerful automated workflows based on actions. Also, and I actually do this on some of my projects, you can actually trigger an actions workflow via an API. You don't have to have anything have happened on GitHub. You can actually just call GitHub and fire the workflow. So I do that on a number of projects where I have a bot that I run on GitHub for assisting on some of my projects, and it will trigger workflows over in other repositories. And so you actually, even if you don't want to run it on specific events, you can manually trigger it. And so let's have a little look at some examples of what people are doing. So the other thing to say is you don't have to write all of these workflows yourself. There's hundreds and thousands of these things that have been built and shared by the community. There you go. When I looked yesterday, over 17,000 community contributed actions. So let's have a look at some. This one is maybe you were on a project that already uses this one. Based on some configuration, this will close an old issue or a stale pull request after a particular point in time. This can be good for maintenance of projects where people maybe leave drive-by comments or something, and then you can set this up to say, if there hasn't been activity for 2 months and nobody, add a label to say it's stale, and then if nobody responds after that, then close it after a week. These are all configuration based, but this is one that is used a lot by the community. This is kind of fun. This is more of a recognizing that new contributors to projects are a thing worthy of celebration. And so this is a workflow that when somebody makes their first contribution to a project, it'll say whatever you want it to say. So it might say, amazing, welcome to the project, you're a hero, we're so pleased to have you here. You can customize what it says, but the point is it's an action that it checks for every pull request. It checks if it's the first time that user's contributed, and then responds as you decide. So this is kind of a nice one for community management. Maybe this one's a little bit more. It's a good one. It's a good one, Joe. This one's a little more close to sort of a standard dev thing. This is a node environment action, and what I mean by that is it will when it runs, you can see on the steps in the docs here, it runs and instantiates a node JS environment version 16, I guess, and then by default runs these npm CI and npm test. You can configure what it does, but it gives you a node environment for your tests to run in. So there's tons of examples like this: Python environments, Rust environments, Ruby environments, C# environments. But this is a very common action that you'll see where people are maintaining a high quality language environment for initializing the test environment. This one is actually built and released by the AWS Code Guru team. So I don't know if any of you have used Code Guru is an AWS service, and this is an action that if you use that service, so I think you have to configure it with your an AWS token. But the one thing to say is the GitHub actions, there's a secrets environment, so you can expose private tokens to the workflows without having to encode them in the YAML. So you configure it to work with your AWS account, and then it will run Code Guru. And again, maybe you use Google Cloud Functions. Maybe you manage, you use sort of serverless compute in the Google Cloud. This is a task that will deploy a cloud function. So this would most likely be running on a project that is on a repo that is actually describing a cloud function. And then finally, maybe every time a pull request is merged, you want to send a text message to somebody. I don't know. You can imagine lots of different things, but this is a integration by Twilio. Again, so it will, you decide what rules you want, but this is a GitHub action that integrates with the Twilio SMS API. So if you wanted to, every time an issue is opened, you could send a text message, or every time somebody moves an issue between repos, you could send it. You can configure it to be triggered however you like. The point is the Twilio lab, so the Twilio service product have actually built and published this action. This is kind of a fun one. Okay, so last but not least, I wanted to spend just a little bit of time talking about code spaces. My understanding is that some of you have used this already, but in some sense, code spaces, especially with all this automation and setup, is one of the sort of ways that I think is really a sort of culmination of making developer productivity as high as possible on new projects. So code spaces is mostly a paid for product, but there is a free tier. So as an individual, you get 120 core hours per month free, which effectively, because the smallest host you can get is a 2-core Linux machine, is 60 hours of CodeSpaces use. But essentially, this is a cloud-hosted dev environment that boots in seconds. It's something we use extensively at GitHub, and it's kind of changed how we do our work. So I thought I'd show you just a little bit what that workflow looks like on GitHub. So this is github.com/GitHub/GitHub. So hopefully no surprise that we use GitHub to build GitHub. This is the project. Took a snapshot of it internally this morning. And so in the repo, you can see there's this folder called devcontainer.json, or a dev container folder, and in there's a file called devcontainer.json. And what this means is for this project, we are versioning the configuration of the environment that's needed to run this application. We're keeping that right with the code base. So as the code base changes, as dependencies are updated, we maintain a compatible dev environment. And so on the code button where you can clone or over Git or SSH, there's also an option to start a code space. And so I didn't have any running here, so I can create a code space, or if I have one that I'd run before, it would show up here. Or I can, I can stop and start multiple code spaces at a time. There's not a limit on that. And then, so if I click create a new code space, literally about 10 seconds later, this is now a screenshot of my browser. I'm in a VS Code web-based session. And you can see, I don't know if you can see in there's a terminal here. We've got the left-hand navigation here is now the source tree. That's the code for the project. And it's saying run script server to run the app. So again, GitHub uses this convention. Script server is how you run the app. And so this is starting in a web browser by default. I'll show you some other ways that can run in a second. So I run script server, and then I get my own personal version of GitHub that was running on this opulent orbit, whatever URL. It's this URL is dead now because I've shut the code base down. But it's running on a particular a private host for me. And all the port forwarding, all the way that this is configured is under my control. And as you can see, and this is the homepage. If you're logged out GitHub, and it's telling me there's some markup error, so maybe I broke something. But this is in debug mode because it's in development mode. But point is, this is seconds later. Just as background, the prior to this, on a pretty fast Mac laptop, it would take about 6 or 7 hours to first set up the GitHub codebase running on an engineer's machine at GitHub. And then because we deploy to GitHub about 60 or 70 times per day, the codebase is continually changing. So dependencies might change. You might need to reinitialize the app. Seed data might change. So there's thousands of people working on this codebase. So you're continually rerunning that script setup, script update. Like, it's continually running these tasks to get a dev environment that works. And essentially all of that goes away with Codespaces. You get the host, you get a default image, you get default dev environment that works, running in seconds. And so when it's up and running, so now I'm just got another screenshot here. You can see that it was called Opulent Orbit. You can see it's running there, it's active. And so you manage your Codespaces from the GitHub UI, and you can actually open it in a range of IDEs. So I could have chosen to open that in Visual Studio Code on my laptop locally. You can open it in JetBrains or JupyterLab if you're doing like a data science project, something like that. So Codespaces is, as I said, there's a pretty generous free tier. It's enough to get you up and running. The Codespaces actually runs by default and for about 30 minutes after 30 minutes of inactivity, it will shut itself down. So you won't burn all your free minutes if you leave a session open. And there's a bunch of starter templates. So the one we have for GitHub is quite extensive, the dev container .json file, but there's a whole bunch of blank ones: Ruby on Rails, React, Jupyter, Express, Next.js, Django, whole bunch of pre-configured templates that you can use to get up and running. And they are, again, just fairly straightforward machine readable files. So let's just have a quick look at the React one. This is a fairly basic example. So again, it's in a dev container .json file. You say how many CPUs you want. It's based on an image that we can see here coming from Microsoft registry. And then there's a whole bunch of pre-configured variables. So like post attach, once the machine is up and running and attached, this Codespace will actually run npm start when it boots. And we will in the IDE, so if it's on the web, it will open app.js just by default. And we can see that we're forwarding port 3000, so making that available. So that will then immediately become available to you in the session, so you can run a browser and see the code up and running. This is the sum total of this configuration file is about 26 lines. For GitHub, for the one I was running, it's about 400 lines long because there's tens of services that we have to run and bootstrap and initialize. We use like a 16-core machine with like 64 gig of RAM for running the GitHub app because it's such a computational intensive app to run. But this is sort of a minimal version of that. Okay, so I think that's about it. I was going to say, so covered today, working what we could do to adopt some conventions that we see in open source. Hopefully gave you a bit of taste of what you can do with GitHub Actions. And hopefully the Codespaces is relevant and interesting to this group and can help you focus on writing code and not bootstrapping environments for all your days. Thanks so much.
Brilliant. Thanks so much, Arfon. There's loads of good food for thought in there, actually. There were quite a few things I was like, oh gosh, we need to tidy up and add some of those elements, particularly around the setup of the open source bit. So does anybody have any immediate questions for Arfon while he was here? Wow. Well, I'm going to be asking people to set up the GitHub Actions. I absolutely love the first interaction message and stuff like that.
Yeah, it's really that's nice a fun touches. One. Yeah. There's there's other ones that can if you use like particularly unfriendly language, it will say, hey, like, did you mean instead of this is a terrible plan, did you mean I wonder if there's a better approach here or something? It's like yeah, quite fun. Yeah, Dave, there's a free tier. It's actually there's only been a free tier since November, so yeah, definitely encourage you to take a look. Yeah, it's definitely makes it a lot easier to experiment with. So
yeah, the intent, just so everybody realizes, to use this with all the STA projects to prevent the headache people are having with setup, basically. Martin was with us this morning, and we've got 2 newbies who've joined the volunteer project who are having lots of fun installing, I think it was Node.js, isn't it? So yeah, the idea is to help people get up and running as quickly as possible. Cool, brilliant. Right, well, thank you. If there's no questions, Arfon, thank you so much.
Of course, no problem.
Really appreciate
I'll send my slides through in case that's useful, so you'll have them as well. So yeah, I'll send those through shortly. I just need to figure out how. Is a PDF okay? Is that fine?
Yeah, absolutely okay. Fine. Yeah. And then we attach it to the. These are all available on Vimeo on Catch Up and YouTube
nice.
as
Great.
well. So
great stuff.
Brilliant. Thank you so much.
All right. Well, thanks again, and good luck with all the volunteering and all your projects. And yeah, see you again soon.
Okay.
Cheers.
Bye
folks.
now.
Cheers. Bye-bye. Thank you. Bye.